This video is about Activity 3.13 or Section 313. You're trying to maintain a healthy lifestyle. You eat a well-balanced diet and follow a regular schedule of exercise. One of your favorite exercise activities is a combination of walking and jogging in the nearby park. On one particular day, it takes you 1 hour and 18 minutes or 1.3 hours to walk and jog a total of 5.5 miles in the park. You are curious about the amount of time you spend walking and the amount of time you spend jogging during the workout. We're going to let X represent the number of hours or part of an hour you walked, and Y represent the number of hours or part of an hour you jogged. Write an equation using X and Y that express the total time of your workout in the park. The total amount of time it takes us to walk and jog is 1 hour and 18 minutes or 1.3 hours. And we were doing both walking and jogging. So this is what we want, total time. And our total time was this 1.3 hours. So the amount of time X that we spent walking plus the amount of time that we spent jogging, which is Y, when we add those together, it will give us the total amount of time that we spent doing both walking and jogging, which was 1.3 hours. You walk at a steady speed of 3 miles per hour for X hours. Write an expression that represents the distance you walked. So it was 3 miles per hour, and we did that for X hours. So if we multiply those together, it will give us the number of miles that we walked. You jog at a constant speed of 5 miles per hour for Y hours, and so that expression would be 5Y. Write an equation for the total distance you walked and jogged in the park, and so we walked a total distance of 3x, plus we jogged a total distance of 5y, and that equals the total distance we walked and jogged, which was 5.5. Okay, so we have these two equations, x plus y equals 1.3 and 3x plus 5y equals 5.5. So that's these two equations right here. Note that neither equation in this system is solved for x or y. One approach to solving this is to solve each equation for y in terms of x. So solve x plus y equals 1.3 for y. So if I do that, I would just subtract x from both sides, and that would give me y is equal to 1.3 minus x. And if we solve the second equation for y, first I would have to subtract the 3x from both sides. Would give us 5y equals 5.5 minus 3x, and then we would have to divide by 5 on both sides. And that gives us y is equal to 1.1 minus 3/5, which is 0.6x. And I think decimals in this case are going to be better for us than fractions. This already has a decimal in it as well, so solve the following system algebraically using the substitution method. So since both of these equations are solved for y, so this one we have is y equals 1.3 minus x, and this one is y equals 1.1 minus 0.6x, we can set these two equations equal to each other, and that would give us 1.3 minus x, equals 1.1 minus 0.6x. And now we would want to solve this for x. So we're going to add 1x to both sides. So remember, this is the same as 1x. And that gives me 1.3 equals 1.1. And then 0.6x plus 1x is plus 0.4x. And then we're going to subtract 1.1 from both sides. And 1.3 minus 1.1 is 0.2. So that gives us 0.2 equals 0.4x. And then divide by 0.4 on both sides. And so that will give us x equals 1/2. Or 0.5 if you'd rather have it that way. And then plug 0.5 back up into either one of these two equations, and it should give you the same value. So y would be equal to 1.3 minus 0.5, and that gives you 0.8. And same with if we plug it in here, and we'll just show you that just so that you can see that you'll get the same value. Y equals 1.1 minus 0.6 times 0.5. And that's y equals 1.1 minus 0.3, and subtract that from 1.1, and you get 0.8, just like we did with the other equation. This was the amount of time that we spent. Yeah, this was the amount of time that we spent walking. And this was the amount of time that we spent jogging. And so if you wanted to convert that back to minutes, what you would do is multiply this to 60. 1 hour is 60 minutes, and so if you wanted to convert it to minutes, you would multiply this to 60. And so 60 times 0.8 would give you 48 minutes. Not necessary. I would be totally fine with you leaving it as 0.8 hours. For now, you can just skip this part, checking it on your graphing calculator. We'll talk about that in class if I feel like we need to do that. Next, we're going to look at something called the addition or the elimination method. And so whenever you have a system that's in this form, substitution would be okay for this problem because you can easily solve this first equation for x or y, but this second equation leads to more decimals and fractions than we originally had. And so if I was going to do substitution on this, I would solve this for either x or y. It doesn't really matter which one you solve it for. If you solved it for x, you would subtract y from both sides, and that would give you x equals 1.3 minus y. And then I would take what we got for x, which is this 1.3 minus y, and I would put it into x in this equation here. And so that would give you 3 times the quantity, we'll put that in red in the middle there, plus 5y equals 5.5. So this is the way that I would do substitution on this particular problem. And in the parentheses, we put the 1.3 minus y. And then you distribute the 3. 3 times 1.3 is 3.9. And then minus 3y, and then plus 5y equals 5.5. So we have 3.9 and negative 3y, and positive 5y is plus 2y. And then we would subtract 3.9 from both sides. That would give us 2y is equal to, and 5.5 minus 3.9, whoops. That gives us 1.6, and then when we divide this by 2, we get y equals 0.8, just like we got before. And we'll get the same value for x, we'll get 1/2. And what you would do is take this 0.8 and just plug it back up into this equation right here for y. And 1.3 minus 0.8 does give us 0.5, just like we got before. The addition method, however, you add the right-hand side and the left-hand side of the equation together, and they're just wanting us just to do this just as the equations are right now. Oops, that should be a 1.3. So if we add these together, x plus 3x is 4x, and y plus 5y is 6y, and 1.3 plus 5.5 gives us 6.8. So this doesn't help us any, because it gave us an equation that involves both x and y. Well, we already had two equations that had x and y in them to begin with, so having this other equation with both x and y doesn't help us at all. So what we do is we take one of the equations, we multiply every single term in the equation by something, so that when we add it to the other equation, we'll get 0 for one of the variable parts. So what they did was they took this first equation and multiplied every single term, the x, the y, and the 1.3 by -5. So that gives you these equations here. So now if we add these two equations together, what do we get? Well, -5x plus 3x is -2x, and -5y plus +5y is 0, and -6.5 and 5 plus 5.5 is -1. So this is exactly the same as -2. Now 0 times y is just going to be 0, so we have -2x equals -1, and then we divide both sides by -2, we get x equals a half, just like we got before. And then to figure out y, you would plug this into one of the original equations. It doesn't matter which one you plug it into. I usually try to plug it back up into one of the easier of the two equations, and the easiest of the two equations was the x plus y equals 1.3. So we would take the 0.5 hours and plug it in for x. So that would be 0.5 plus y equals 1.3, and then you subtract 0.5 from both sides, and you get y is equal to 0.8. Okay, so we get the same solution that we got before. Okay, so again here they're just having you compare these two systems. This one was the original system. This is the system after we multiply the first equation by -5. Alright, so this is actually just having you go through and solve it. So we will skip through all of that. And here's another system for us to solve using the addition and method. So this lends itself to the addition method because if you try to solve this equation for x or y, it doesn't matter which one, it will cause you to have fractions when you try to solve it. So because you'd either have to divide everything by 2, which is going to cause a fraction here, or you'd have to divide everything by 3, which is going to cause two fractions with the 2's. This one, we'd have to divide everything by 3, and that would cause fractions with both of these. If we were to try to solve for y, we would have to divide everything by 5, causing the other two terms to have fractions in them as well. So the substitution method is not really a great method for this. So what we want to do is we want to multiply these equations by something so that when we add the two equations together, we're going to end up with 0 for either the x's or the y's. It doesn't matter which one. I'm going to choose the x's just because they're slightly smaller numbers to work with. And so what we want is we want to multiply, and so notice you can't just multiply by one of the equations by something, because there isn't anything I can multiply this 2 by that will give me this 3. So we need to multiply both of the equations by something so that we get the same number but opposite signs. And so what we want is just like we were finding the least common denominator, it's similar to that. So we want the common multiple of 2 and 3, and the smallest one. So that would be 6. And the thing that I can multiply 2 by to get 6 would be 3. So I'm going to multiply this entire equation by 3. And the 3 I would have to multiply by 2. I want one of them to be positive and one of them to be negative. So I'm going to multiply this one by negative 2. Remember, you have to multiply everything in the equation by these numbers. So we're going to multiply the first equation by 3. That's going to give me 6x plus 9y plus 6. Oops, sorry, equals 6. And then we're going to multiply this entire equation by negative 2, giving me negative 6x minus 10y equals negative 8. And then we're going to add these two equations together. And 6 and negative 6 is 0, so you don't even need to write that down. And then 10y minus 10y, sorry, oh my gosh, 9y minus 10y will give you a negative 1y. And then equals 6 plus a negative 8 is negative 2. So we have negative y equals negative 2, which means y equals positive 2. So you can either think of multiplying both sides by negative 1 or dividing both sides by negative 1, either way. Now that we have y, we're going to substitute what y is into either one of these two equations. It doesn't matter which one you choose. I'm always going to use the first equation in class, but you could use the 3x plus 5y equals 4 equation, and you would get the same result. So it's going to be 2x plus 3 times 2 equals 2. So we have 2x plus 6 equals 2. And then we're going to subtract 6. And we get 2x equals negative 4. And then divide both sides by 2. And we get x equals negative 2. So now we can check our solution. We got the solution negative 2, 2. And this is a point. These are two lines, remember, and we're trying to figure out where they're intersecting. And we found the intersection point to be negative 2, 2. So we can check our solution. We just plug our solution back up into the original. So we would have 2 times negative 2 plus 3 times 2. Does that give me positive 2? Well, we get 2 times negative 2 is negative 4, plus 3 times 2 is 6. And yes, that does in fact give me 2. Now check our solution in the second equation. That would be 3 times negative 2 plus 5 times 2. And we want to know, does this give me 4? Well, here we have negative 6, and then plus 10. And yes, that does give you 4. And so both of them worked. So this is stepping you through the substitution method. Again, it's the same system that we've solved several times already, so we're not going to go through and solve that one again. So here's another one for us to solve, and they want us to solve it using the substitution method. We'll actually do it both ways. We'll do it using substitution here, and we'll do it with the addition method here. So for the substitution method, I would solve this for x. The reason that I want to solve it for x is because I have a negative y. So that way I'll keep all my variables positive, which is really nice. And so this will give me x equals y plus 5. So now we're going to take y plus 5, and we're going to put that in where the x is in this equation. So we're going to take this red rectangle and replace this x that has a circle around it. So that would be 4 times the quantity, and we're going to replace this empty set of parentheses with the y plus 5, and then plus 5y, and it equals negative 7. So I have to distribute this 4. That gives me 4y plus 20. Plus 5y equals negative 7. And we have 4y and 5y, that's 9y. Plus 20 equals negative 7. And then subtract 20 from both sides. We get 9y equals negative 27. And then divide by 9. And we get y is equal to negative 3. So now we're going to take what we got for y, this negative 3, and we're going to plug it back up into this y here. That'll give me x equals negative 3 plus 5, which is 2. So we have the point 2, negative 3 is where these two lines are intersecting. Again, you can check this solution simply by plugging a 2 in for x and a negative 3 in for y and checking to see if you get true statements here. So now let's do this one using the addition method. That means I need to multiply this one of the equations by something so that when I add the two equations together we get a variable that cancels out. Well, notice this y is negative and this y is positive, so I'm going to multiply so that my y's end up canceling out when I add the two equations together. And so I would have to multiply this first equation by 5. And that will make this a negative 5y, and it'll cancel with this positive 5y. So we'll have 5x minus 5y equals 25. That's multiplying the first equation by 5. And then we're going to add that to 4x plus 5y equals negative 7. 5x plus 4x gives you 9x. And negative 5y plus 5y is nothing. And 25 minus 7 is 18. And then we're going to divide both sides by 9. It gives us x equals 2, which is exactly what we got before for x. Now take this x equals 2, and you can plug it into either one of these two equations. It doesn't matter which one you use. I'm going to plug it into the first one. So that would be 2 minus y equals 5. Subtract 2 from both sides. And now this is negative y equals 5 minus 2 is 3. And multiplying or dividing both sides by negative 1 gives you y equals negative 3. So we have the solution to negative 3, which is exactly what we got when we solved it using the substitution method. I happen to lean more towards using the addition method, unless for whatever reason one of my equations is already solved for a variable, and then I'll use substitution. But that's about the only time that I ever use substitution method. You will need to know how to do both methods for the exam though, so make sure that you know how to use both of them, and you'll be told which method that you need to use. Okay. So the last question is just to check the answers that we got. So we're going to check this and make sure that our answer is correct. We're just going to check it once because, of course, we got the same solution. So plugging 2, negative 3 into the first equation gives us 2 minus a negative 3 equals 5. And remember, minusing a negative is the same as plus. And so we have 2 plus 3, which is equal to 5. So that's true. And then plugging 2, negative 3 into the second equation gives us 4 times 2 plus 5 times negative 3. We want to know if this is equal to negative 7. And 4 times 2 is 8. And then 5 times negative 3 is minus 15. And that definitely is equal to negative 7. And so both of our solution worked in both of our equations. And so our solution is correct. And that is the end of this lecture. Let me know if you have any questions. Thanks.